Okay, next topic adalah interval estimation of the mean response. Okay, kali ni saya tukar sikit gambar tu supaya you all tak boring tengok muka saya. Okay, alright, so we start. Okay, a common objective in regression analysis is to estimate the mean for one or more probability distribution of y. Okay, we can estimate the mean of y. That is one of our objective when we are doing the regression analysis, right? Let's see here. Let x hash denote the level of x for which we wish to estimate the mean response. Why? Okay, x hash may be a value which occurred in the sample, or it may be some other value of the predictor variable within the scope of the model. So x hash ni, x kat sini kita boleh replace dengan x hash when we want to estimate the response variable, the mean of y. The mean response of x equal to x hash is denoted by expected of y hash. Ini notation untuk mean response. The point estimator for the mean response, it can be written also as y hat h. Okay, when we want to find the mean of the point estimate for mean response. This is the formula to find the mean estimate for to estimate the mean response. Okay, how to get this? So actually daripada sinilah sebenarnya, but no need for you to no need for you to hafal how we get this formula. Tapi inilah dia punya idea how to get this formula. Okay, expected of y hat hash. We know that y hat adalah beta naught plus beta 1 x hash. Okay, so now kita nak cari mean of the response. So we replace y hat here. Okay, when x replace with the any value ataupun level of x. Okay, expected of beta naught adalah value, kan? So mean for beta naught will be the value itself, the beta naught. Yang that you have learned in probability and statistics dulu, kan? Okay, and then expected of B1 XH will be XH expected of B1. So expected of B1 adalah B1. Okay, so because of that, untuk dapatkan mean response, we will use the formula of beta naught plus beta 1 XH. Beta 1, you know how to get this. We can estimate the beta naught and beta 1. The parameter, we can estimate these two parameter with the formula that you have learned before this. Okay, so sekarang kita nak tengok macam mana nak cari confidence interval for mean response. Right, this formula that you are familiar with before this in diploma level. So kita akan jumpa lagi sekali kat sini. Nak cari confidence interval for the mean response. So according to this formula, we need the value of y hash ataupun the mean estimated of the mean response tadi, which is the beta naught hat plus beta 1 hat multiply x hash. X hash adalah any value ataupun the level of any level of x. Tergantikan, we replace x hash in the regression equation, which is x. Okay, plus minus t table 1 minus alpha over 2 and minus 2 dia punya degree of freedom. So same here, like I said before this, if we use the t table from the textbook, kita akan gunakan dia punya significant level will be 1 minus alpha over 2 because of the t table kat sini adalah t table less than. Tapi kalau you gunakan table merah yang you ada tu, kat sini will be alpha over 2. Okay, alpha over 2 and minus 2 multiply the standard deviation of the mean response. Okay. Okay, this is the formula to estimate the variance of the mean response. It is MSE multiply 1 over n plus XH minus X bar square divide dengan SXX. Okay. KXH here adalah level of X that we replace in X. Okay, we put here XH minus dengan X bar divide dengan SXX. Alright, so when we have estimate the variance of the mean response, then we can have the value of standard deviation of the mean response. Then we can apply this formula to find the confidence interval for the mean response. Let's see the example here. Still the example from the Toluca company. Okay, let us find 90% confidence interval for the mean response when the lot size, which is level of X, is 65 units. Using the earlier results, we find the point estimate. Okay, using the earlier result of the uh, regression equation, and from that we can have the equation of the mean response. Then we replace in the formula 65 here, which is the level of X, then we'll get 294.4. And then using the formula that we have for the estimated variance of a mean response. So this is the MSE 1 over sample size plus XH minus dengan X bar square divide dengan SXX. You know how to find this. Okay, so we get 98.37. Lastly, we can square that value to get the standard deviation for the mean response. Then apply the formula. Hence, we need to get the value of the critical value from the T table with the significant level adalah 90%. Okay, it is 1 minus alpha over 2 kat sini kalau you gunakan statistical table yang merah, so it will be 0.1 divide by 2. So kat sini you akan dapat 0.05 and 23. So lastly you will get the same answer 1.714. Then apply in the formula and you will get this confidence interval. Then you need to know how to interpret this confidence interval. So from this value we can interpret that with 90% confidence ataupun with confidence coefficient 0.9 that the mean, okay, this is sebab kita cari confidence interval untuk mean, so kat sini will be the mean of y. Okay, we are 90% confident that the mean of y required when lots of 65 unit, lots ni adalah x, okay, kat sini adalah y, di sini adalah x. Okay, when mean of y, the mean of y when x level is 65 units are produced is somewhere between these two value. Kena letak dia punya unit. Okay, that is the way how you interpret the confidence interval when we find the confidence interval for the mean response. The next one adalah prediction of the new observation. Okay, as you know, our one of the objective adalah to estimate to find the regression function that we can use that to predict the new observation. Okay, so from there we can find also the confidence interval for the new observation. Okay, in your textbook, it is on page 58. The formula is here. Okay, this is the way how you find the confidence interval when we are estimating the prediction. Okay. Okay, so here we need the value of y hat h, which is the predict value when we have xh, level of x adalah xh, and then we'll also need the standard deviation of the prediction. Okay, so for this level, you need to know the formula of the variance of the prediction. Okay, later dalam subject mathematical statistics, you will know how to prove this. Okay, so using the formula, whether you use the first one or the second one, okay, it's the same, you will get the same answer. Okay, it is MSE plus S square Y hat H, which is the variance of mean response tadi, ataupun MSE over multiply 1 plus 1 over the sample size plus XH, which is the level of X that we replace in X, minus X bar square divided dengan SXX. Okay, so let's see the example. So from here, kalau kita tengok kan Y hat tadi, okay, nak cari Y hat ni, the value sama dengan will be the same. The formula will be the same as the mean response. Kan, sebab tadi earlier we have proved that we see how we get the formula of the mean response. Okay, so first of all, we need to have this value, which is we have the regression function, and we replace xh. See here, xh adalah 100 in the regression function. So you will get this y hat, the prediction of y. Okay, let's read the question first, the statement first. The Teluka company studied the relationship between the lot size and work hours, which is the lot size adalah x and work hours adalah y. Okay, to obtain the information on the mean work hours required for different lot sizes for use in determining the optimum lot size. Okay, so from here, daripada ayat ni pun kita dah boleh tahu ini adalah y, ini adalah x. The company was also interested, however, to see whether the regression relationship is useful for predicting the required work hours, which is y, for individual lots, which is x. Suppose that the next lot to be produced consists of 100 units and that a 90% prediction interval is desired. Okay, so our xh will be 100. So from there, we can calculate the value of y hat. And then we need to have the value of S square prediction. So from there, you can use this value as well. Ataupun boleh gunakan this formula as well. Tak ada masalah. Okay, so lastly, you will get the standard deviation of the prediction is 50.87. So apply the formula. Okay, apply the formula, this formula. Lastly, you will get 332.2 and 506.6. What we can interpret here with confidence in coefficient of 0.90 ataupun we are 90% confidence that when we predict that the number of workers, which is y, for the next production run of 100 units xh tadi will be somewhere between 332 and 507 hours. So we can predict that the work hours will be between these two values when we are produce 100 units. So if in reality we get the prediction when we run the production, we get the number of hours, which is y, is more than this value. So means that the manager can know whether that the production is overwork or something like that, and then the manager can take action from there. Okay, dia boleh buat inspection from there. So daripada situ kita boleh tengok the manager boleh control about the production. and the work hours. Okay, that is the use of the confidence interval for the new prediction. Okay, okay, that's all actually.